If not, how do we come out of it? And we're also going to introduce this concept called local data-oriented architecture today. So before we get into all this, I have a very simple question for you. What if a bank asks you to fill this application form to open a bank account? How many of you would proceed dealing with that bank? Anyone? Wow, that's a lot. Okay, now I may have to change my speech. Anyway, so the point I was trying to make is customer experience is what is driving a business's revenue today. If, most of us, personally, I wouldn't probably go to a bank that would want me to fill an application form. I would instead search for a bank that would allow me to open an account online because that makes my life easier. So customer experience, a lot of businesses are using this as a means to drive a lot of revenue for their business. But even then, they find it challenging to provide unmatched experience to customers. So what is the challenge, actually? The thing is, customer expectations is a moving target. We all know that all our expectations have taken a great turn in the last few years. We expect everything to be online today. But that's not the end of the story. It keeps changing at a very rapid pace. That's why I call it a moving target. Let me explain this with an example. Let's say I have Alexa, and it tells me that it can pay my power bill. I did not know that before. I didn't know that it was capable of doing that. But the moment I hear it, my mind races. At that instant, I expect it to pay everything else, like my grocery bill, transfer money to kids, pay the mortgage, and book a salon appointment, and so on. So at that one instant, I have reset the target that all the other businesses are working towards. Maybe the grocery store is still struggling to even create a mobile app, and I'm expecting it to interface with Alexa. So as you see, as a customer, my expectations see no business boundaries or industry boundaries. When it comes to digital experience, any business in any corner of the world has the ability to reset targets for all the other businesses. So your competition is no longer within your industry, it's across the entire world. So who is resetting this target? Who is the one that exceeds a customer's expectation every time? With customer expectations rocketing sky high, it is usually startups that go above and beyond and exceed a customer's expectation. We all know how Uber disrupted this taxi industry, and we have other examples like Airbnb and so on. But on the contrary, large enterprises sometimes struggle to even keep up with these changing expectations. How many taxi industries lost their business after the advent of Uber? Why couldn't they provide that experience, digital experience, quickly? It's because I guess there is a basic difference between startups and incumbents. Hello.
Sorry.
That's all right.
Guy with the biggest head in the front, sorry.
Yeah, we're just talking about hunter-gatherers here. So what is the difference between startups and incumbents? I guess the fundamental difference is we all know that startups are born digital. They're born in a world where digital experience is prevalent. And so customers are front of mind for them from the beginning. They don't entertain paper processes from the beginning. Whereas incumbents that have been in this industry for several decades now still have to deal with legacy systems, legacy processes, and business models. Because these systems were created at a time where digital experience was non-existent. Even internet was non-existent for that matter. So how does it feel like being in this legacy world? For those of you that have not dealt with any legacy systems, if you're that fortunate, then let me just give a bit of a background. I'm talking about systems like mainframes, JD Edwards, SAP, and so on, that were built a few decades back, and they were supposed to be doing end-to-end processing of the entire enterprise, right, from back-end to middleware to front-end, and so on. These systems work very well even today, but just that they don't meet today's needs. Why is that? It's because they have two main challenges. One is they have lack of data insights. Let me explain this with an example. Let's say we have a travel industry and they work with a legacy booking management system. This is a sample flight booking data that you can see in the legacy system. You and I can't understand what this data means. We can take a guess, of course, but we wouldn't know until we involve a legacy systems expert to translate this data for us. Imagine putting this data out to customers, even in a translated format. Do you think this is good enough to attract a customer to exceed their expectations? Maybe not. In fact, some of this data is so business oriented that people would get annoyed by seeing it, like flight code or aircraft type. Why would I care? And the other problem is lack of data access. In many organizations, even today, real-time data is only present within your legacy systems and nowhere else within the enterprise. You may have systems like data warehouses and etc., but they only store historical data. So if you want to get hold of a booking record that happened a few minutes back, you would have to go all the way to legacy systems. And the problem is that data layer is covered with an application or a service layer, which means you can't just go to these systems and say, hey, show me all your data, I'll choose what I need. It can't answer to such requests. You would have to go to it with specific requests like, give me this customer's data from this time to this time, and then it can come up with a response. So if you're living in this world, I'm sorry to say, you're all living in the world of data hunter-gatherers. You know how hunter-gatherers had to go all the way to forests to hunt for food, and they spent so much time, and only to realize that the food, can't be consumed immediately. They'll have to cook it, clean it, and then only eat. Just like that, you're going all the way to your legacy systems every time you need data, and you realize that you can't consume it. You need translations. You need layers of translations and processing to even start making some meaning out of it. Those days, it was okay for hunter-gatherers to spend one whole day to prepare one single meal, and they would have to start the process all over again next time they're hungry. But what world are we in today? Today, cooking is just a part of my day-to-day activity. I would rather spend my time more productively. Similarly, your technology team should actually focus on customer experience or innovation because that is driving your business's revenue, not just moving data around across your enterprise. If you look at startups, they are living in the world of supermarkets, where data access is not an issue for them. They get data all available locally, and most importantly, the data is consumable. You go to a supermarket, get a bread and cheese, and you can make a meal quite easily. You don't have to worry about hunting or processing and all that. That's usually because most of the times the data is available on cloud, so access need not be an issue. But most importantly, because all data is available in one place, they derive insights in real time. So when a customer makes a flight booking, they not just store the booking, but they try and derive insights, like what is the average spend this customer makes on a flight? How much has he saved today? And imagine putting this data in front of customers. As soon as they make a flight booking, you tell them, congratulations, you've saved $30 on this flight. That has the element of surprise that attracts the customer. How do they do that? They could run machine learning models because they have access to data, and they could understand the customer's usage pattern. Maybe not just with that one customer, but across all customers that are similar to this customer, and so on. So when you have the wealth of data in hand, you can do wonders. But imagine doing this inside your legacy systems. It can be very painful. So if you're living in this world and business comes to you saying, I want to increase the number of bookings for the next financial quarter, and so let's start providing personalized discounts to customer. And to do that, we need to understand what a customer's favorite destination is. Where is he going to travel in the next 3 months? How would you know that? This is where experimentation comes into picture. So business says, I don't know how we calculate it. Maybe let's just start with this hypothesis that the most frequently traveled destination is the favorite destination. So go back one year in the history, find the most frequently traveled destination. Let's just put this feature out to customers. We would know if it's a dumb idea or not only if we put it out to customers, right? And in this world, it's just a piece of cake because they have access to data. All they need to do to develop this feature is all about creating a query, and then they put it out to customers. And it takes days. And then let's say they get a feedback saying, well, this is winter and summer holidays. I would rather get discounts for a holiday than for my official trip. And then you realize, all right, so maybe I need to include factors like time of the year. And maybe I need to go back 5 years down the line, not just 1 year, to improve the accuracy of my algorithm. So it is a change, but the change is just in one place or in your query. Or if you have a machine learning model, it does that automatically. So this is what is happening in startups. But when you look at the same scenario in a large enterprise with legacy systems, this developer has absolutely no access to data. All he or she has access to is an API catalog that has a booking API. So she says, okay, so I'm trying to get a historical booking from this API, only to realize that this booking API only provides upcoming bookings, not historical bookings. What can she do? So she involves the integration team, asks them to update this API to include historical bookings. And then the integration team says, I don't get that today from the backend team, so I'm going to involve the legacy team as well. They're going to help me translate this pipeline delimited text into a JSON format that will provide me the historical booking. Great. And then the integration team goes about changing the APIs, only to realize that, oh, this booking API is being used by the front end. They show upcoming booking on the mobile app. And it is also being used by my P2P customers, by my marketing team, by other teams. It's too risky to change this API and include historical bookings. You don't know what is going to break. It's going to be time consuming. Let me just go and create another API. That's all right. At least now you have the historical data in hand and you can finally deliver it to your customers. But mind you, this data is not as wealthy as the data you had in the startups, but you have some JSON message. So you aggregate all the destination and you try to find the most frequently traveled destination and you put it out to customers. It's taken weeks already. And then you get a similar feedback. You have to go 4 years down the lane. Can you do that by yourself? Is that a change in one place? Mostly not. Most of the times you would have to go through all or most of the process all over again. So if you compare the two scenarios, they have only made 2 attempts, but it is 1 month already. And they have still not nailed the algorithm. But these startups, they have taken 1 month, but they have made several attempts to improve the accuracy of the algorithm, and the number of bookings is spiking. So as a business, they are seeing success because they're able to predict very well where the customers are going to go. And they also started attracting new customers from these incumbents. But these incumbents have not only invested a lot because they had to invest across multiple teams and technologies, but they have also started losing customers to startups. This is how, in reality, large businesses are losing to startups. So if you see the fundamental difference between the two, to these guys, for startups, data was within their reach, so they were able to make wonders. But for these guys, they had to go through a lot of processes and obstacles to get hold of the same data. We keep talking about data being the new oil, data is the asset of your organization. Then why keep hiding the data within your legacy systems covered with layers of APIs and services? It is time to liberate data and let the data drive your business value. Gone are the days where business and IT were seen as two separate entities, where IT applications, IT people, and data were all shared between different business domains. We started distributing applications like SaaS application for each business domain. We started distributing people in the name of agile practices and product teams. But in many organizations, data is still largely centralized. I think it is time for us to start distributing data across these business domains. How do we start distributing data? There are many ways to do that, but one of the ways is to introduce a streaming platform like Kafka between your legacy systems and your other business applications. And you can start capturing the changes in your legacy ERPs through change data captures and so on. Now, by introducing this setup, you're kind of creating a supply chain wherein you're getting the raw data from your legacy ERPs and you are populating your data supermarkets, which are those data stores, in your business domains. So when these business domains or product teams have direct access to data, they can now start delivering at the speed of startups. So we call them local data stores, not just because the data is only accessible within the business domain, but also because the data now takes different meaning depending on the context it is in. Let me explain this with an example. Let's say this is a sample booking data of a customer that is traveling from Auckland to Wellington for 5 days and returning. So it's a return trip of a customer. And when I stream this data and when I populate that in a flight management business domain, for example, I can take the data and I can store that as 2 different booking records, not just one booking, because that could involve 2 different flights, which would have 2 different seats, 2 different costs, and 2 different schedules. So it helps me with the business process within the flight management team, because if there is a delay in one flight, it helps me to send notification to just one flight instead of sending for both the flights. So that's why it really helps to split that into 2 different flight bookings. And let's say I have partnered with a hotel management business, and when they get the business data, I mean the booking data, they could store it as one booking if it involves one hotel, or they could store it as 2 different bookings if it involves 2 hotels. So the point here is you no longer are bound to store the data according to the schema or data model that was defined by somebody else in the organization. If you are going to deliver features to customers, you have the autonomy to store the data in the way you want, to index it, to make it searchable in the way you want. Traditionally, we would have created one booking API across all business domains, but we all very well know that that booking is going to take different meaning depending on different contexts. So we were struggling to make it adapt across different business domains. So we intentionally created different versions of the same booking data. We collected technical debt. But this, although we are having replications within enterprise, we are intentionally doing it, and this gives the autonomy to deliver at the speed of startup. The other advantage of this local data-oriented architecture is that it leads us towards event-driven architecture. Let's say I stream change a flight delayed event from a legacy app. Anybody can come and subscribe to this event. When a flight management domain subscribes to it, they have business processes to notify the customers that the flight is delayed. But when a hotel management subscribes to it, they can update their hotel staff about a different time when they have to arrange their hotel, and so on. Let's say there is a new business domain coming in called the car rental. The business has partnered with them and they have come in. They can now subscribe to the same event and they can follow the business processes that they want. So the advantage of this is we have created an ecosystem-like environment in that large enterprise. Just like in our ecosystem, any species can come into existence and go out without disrupting others. Similarly, when you just rip one part of the enterprise, the rest of the enterprise can still function. They are not tightly coupled to each other. So when you look at the benefits of this architecture, the first thing is that it allows us to have a decentralized enterprise where we are not tightly coupled or we're not directly dependent on each other. And the second one is it allows us to have multiple innovation streams. So when you have data distributed between different business domains, each business domain can start innovating at speed. And when such large enterprises also have the wealth of data that is accumulated over several years, imagine the combination of having the wealth of data and having multiple innovation streams. These large enterprises now have a competitive advantage to even lead and grow beyond startups. And the next big advantage is that this allows them to truly decouple from their legacy systems. When you decouple, when you introduce a data layer between, or an eventing layer between your legacy systems and the rest of the applications, then it is true decoupling. But if you have a synchronous API between your legacy applications and the others, it is not necessarily decoupling. There is still tight coupling between these systems. So this is like an overall concept of local data-oriented architecture. But I just thought I'll cover some frequently asked questions as well. So there's this one question that people ask: how do you distribute data? We are intentionally creating replicas of data here. When you take a booking data, we will replicate it across business domains and customer data and so on. So how many replicas are we going to create? Will we end up having thousands of replicas of the same data? Well, we wouldn't have if we orientate this distribution of data around business domains. This is where domain-driven design and identifying the bounded contexts come into picture. What are the other things to consider? There are definitely a few things to consider when we go towards this architecture. One is data reconciliation. Obviously, when we start replicating data, we need to make sure that the data replicas reconcile in real time and they are in sync. The next is cost and complexity. We are introducing a lot of complexity within the architecture. We need to cater for that. Operating model. So I've been talking about domains, business domains. That definitely means you can't still, live in the world of shared services. You may have to rearrange your teams, and that involves a change in operating model. And observability. So how will you know that the local data store hasn't got the data in real time? How can you, set up monitoring and alerting before the customer actually sees the problem? And security. The data that was, for years being just within the ERP system that was secure is now being distributed, and it's going to be, touched by many other developers within your organization. How do you make sure they don't misuse the data, and so on? And before I conclude, I just want to give a few things to note. One is this architecture, as I said, is going to help us with agility, is going to help businesses innovate, experiment, and lead beyond startups. But if you're working for a business that is already monopolizing this digital world, or if they don't worry about competition, if they're happy with what they're doing, or if all they're thinking about is just digital adoption and stop there, but not necessarily digital transformation, then maybe this is not an architecture for them. And keep this as a last resort, because we're doing this to improve a company's agility, a business's agility. And agility is a very relative concept. Maybe you can try other small things like automating, DevOps, and other stuff before getting into this right away. And the last one is start small. Many organizations here are still dealing with shared services teams. And you can't just think of creating domain teams overnight. It is a big process. So start small, start with a small domain, create a local data store for them, see if it works, see if it really brings a good outcome to your business, and then start expanding that across your enterprise. So in conclusion, yes, data hunter-gatherers is not necessarily a good thing, especially if you're looking at digitally transforming an enterprise. But there are ways to get out of it, and local data-oriented architecture is one of the ways. Thank you.
June 2016, cable offered at 149.20, 147, 146, 144.50, 143.10, offered at the 140 handle, 139, 137, 135.20, and at 132.36, the British pound hit a 30-year low. Shouts from the trading floor, we need answers now, what the hell happened? You see, no one knew exactly if or precisely when the market would accept that the UK was leaving Europe in the form of Brexit. But it turns out that there was a tiny city in the place of North England called Sunderland that declared a referendum result that made all the difference. So before I jump into that, I'll just do a brief introduction to myself. My name's Stephen Dewar, and I was previously the global head of Morgan Stanley's Foreign Exchange Core Technology Group. And I spent almost 2 decades engineering electronic trading systems in a journey that sent me from London to New York, back to London, to Hong Kong, back to Shanghai, back to Hong Kong. Along the way, I married a Kiwi, and eventually we decided to pack it all in. And so last year, I moved to New Zealand here in Auckland, where I am now based with my 3 kids, and changed my world completely, moving from investment trading house to working at Xero. And I head up their small businesses department as an engineering manager here in Auckland. So this evening, I'm going to talk to you about event sourcing and really share how we used it on Wall Street for this particular event. And then I'll delve in a bit deeper into some key principles that I'd recommend many consider when you look to move on to such an architecture, and hopefully touch on some of the challenges the approach might bring. So can I just ask in the room, I can just about see you, you've got a small, I've got a small video of you. How many of you have heard of the concept of event sourcing? Okay, cool. How many of those people have deployed a system into a production environment for event sourcing? Okay, cool. Great. This is good. So let me start by describing what is event sourcing. And simply put, it's where you capture all changes to an application state as a sequence of events. So let's think about that carefully. A sequence of events. So everything, absolutely everything that causes a change to your application state must be captured in a sequence of events. It's very concise, but a very clear definition. But what I'm going to do is take you on a journey way back to 1976 to try and elaborate on this further. So why 1976, you may ask? Well, it'll be interesting to know how many of you were familiar with this game, but there was a release of a computer game called The Colossal Cave Adventure in 1976. And just sort of work with me here. It will be a useful example. So you're standing at the end of a road before a small brick building. Around you is a forest. A small stream flows out of the building and down a gully. You choose to go south. You're in a valley in a forest beside a stream tumbling along a rocky bed. You choose to go west. And so the game continues. So it was really a very early text-based, role-based navigation game where you could both choose directions, north, south, east, and west, but you could also choose to pick up possessions, use magic potions, and just generally continue this adventure. Now, the goal of the game was to explore the cave that was rumored to be filled with wealth and acquire the maximum amount of treasure whilst escaping from the cave alive. Even with the fastest possible shortcuts through the game, it required at least 215 correct moves to complete the game. What made it very difficult, as you can see by this third command here, is that repeatedly you would be surprised by falling into a pit and breaking every bone in your body. And so it was very painful to discover all the wrong moves and have to restart the game each time. Now, even back then, despite it not being an online multiplayer game, we had primitive versions of chat channels known as RPC channels, some of you may be aware of, and people would share the moves that they had taken along the game. So you could imagine that you would start to build out a list of the commands that worked. This might look something like this. Combination of directions, instructions, commands to pick things up. And so what people would start to share in these RPC channels would be very simple text files of these types of forms. And slowly but surely, you had a sort of an old school crowdsourcing model trying to find your way out of this maze. Now, a couple of people took this one step further. Ralph Witt and David Platt actually used the command sequence to project a full-blown visual map of the cave that they had imagined, just using the command input stream. The commands were simply retained as the original intent of the user, and this alone would provide these powerful views that could be derived on a projected state such as this map. So the point I'm making here is that the audit logs of your journey were not only useful, but they were actually all you needed in order to provide a truly deterministic view or projection of the system at any state and a point in time. It was the only thing you needed to retain in order to figure out where you were. You didn't need to remember where you were in the game. You just needed to know in a provable log of how you got there. Now, this may seem obvious, but I'm going to work with you on this a bit further. Now, where in the industry would you see other examples of projecting current state, just retaining a log and nothing else? Turns out they're pretty mainstream examples. Relational databases, as I'm sure you're very familiar, have transaction logs. Well, what is a transaction log? A transaction log is an append-only log that has a sequence of all the commands that we used to recreate to the present day state. Pretty much the first line in the command in the transaction log is create database, and then create table, and maybe create another table, adding some columns, adding some rows, adding some indexes, and there you go. If you replay the entire transaction log, you will get it back to its current state. Something a bit closer to home at Xero in accountancy are general ledgers. Of course, you could keep a current balance and you can remember a current balance, but that would be dangerous. It would introduce the notion of an invariant between the current balance getting out of sync with how you actually arrived at that current balance, the series of debits or credits. So instead, what general ledgers do is they just record the debits and credits. And anytime you ask to calculate what the total balance is, you run a function over the debits and credits. So you're always guaranteed to have an integrity through this essentially stateless function that performs over the command log of debits and credits. So let's go back to our Colossal Cave adventure and review the architecture. So here's a sort of traditional CRUD architecture, copyright, update, delete approach. There's nothing wrong with it. I know the name doesn't sound glamorous, but the game here, you can imagine you would have some application service and your state that you might retain would be your current state. So as you move into different parts of the maze, as you saw in the map, you may just remember your location. You may even go one step further. You might remember and have a list of the things that you've picked up. You may record the people you've spoken to. And every time you go in, pick up and drop an item, you increment and decrement these containers. Let's compare this with an event-sourced approach. An event-sourced approach looks at this quite differently. Your database is just your log. Your database has the list of all commands. So if I want to go, if I want to know where I am at any point in time, I just replay all of the instructions and the commands, and I'll be able to calculate every time I ask the question where I am. If my log changes, where I am changes. So I have not only a log, but I have a provable log because it's the only way I can derive my current state. One very clever side effect of this, suppose 5 years down the line, they wanted to put some gamification into this, and they wanted to identify and reward the people who tried the hardest, the people who traveled the furthest and not got out the maze. The way you might do that in the traditional CRUD approach, you add in some new fields called distance. Every time you update the state, you increment the distance by 1. The feature goes live 5 years after the game was created. Great, we'll wait another year or so and then we'll announce the winner. Event-sourced approach, this 5 years on requirement comes in. We'll just replay the log with the new requirement and look back from day 1 and come up with what the distance was since day 0 when the game was introduced. You start being able to do what almost seems like you've predicted tomorrow's features using yesterday's data. Now, obviously, it's important you retain the intent, and that I will talk about a bit later with the importance of domain experts. So let's go back to that day on the 24th of June in 2016. I'll talk a little bit more about what happened. So it was approximately 11:23 a.m. And I say approximately because I spent the weeks following dissecting the milliseconds that surrounded the 23 minutes past 11 o'clock during Hong Kong hours. And that was the major part that the Sterling slide took place. And we never knew these events would occur. In fact, we didn't know they would ever occur. But because of the event source design, we had a full audit, just like an airline black box, just like the Colossal Cave Adventure that we could replay. And so that's exactly what we did. We found the particular point in time where Sterling had dropped the largest it had in recent memory. And we moved the event log onto a parallel production environment, hydrated it with the event log, and changed our second frequency down to minute frequency, and replayed millisecond by millisecond every single movement that fed into our production trading environment. We fed that into our trading screens, multi-desktop, and created a movie with narration and editing, and did some post-production editing. And within hours of the event, had published out a retro to our traders to learn from how they would handle the same experience differently. And we poured through that video in weeks and months to come. Now, this is just one of many examples where the ability to capture high fidelity audit as your data store changes can allow for unimaginably amount of alternative use cases for the data. But this was probably an example of a place that it worked extremely well. But there are some very careful considerations I would recommend. I would suggest that ever since 2014, when not only event sourcing, but the term of CQRS, which is an adaptation of event sourcing for separating read writes through command and query responsibility segregation, became and gained this popular following. And it's been a real danger that event sourcing would almost be applied primarily because it was fashionable. So whilst I believe this approach can produce incredible results, there are some critical considerations I'd recommend you consider. Before I go into these 5, I would just start off with the hopefully clear assumption that you need to ensure that your product's problem space demands the benefits that event sourcing can bring, where you need high fidelity, trusted audit, treated like forensics, and that is actually a need of your customers that will add competitive advantage. But I'm assuming you would have that. So the first thing are your people. Training is required, and it's non-trivial. First of all, you need to have an embedded domain expert, someone who can be the voice of your domain language, someone who can teach your team. It can be a person who's an engineer, it could be a person who's in product, it can be an analyst. But you need to know who is that person who's going to train people on the ubiquitous language and teach a consistent place, not just to your engineers on day 1 when you built the product, but day X when your product continues to be in use and actively changed by your team. Next, you need to build a strong competency in domain-driven design. You don't need to become like Eric Evans, author of Domain-Driven Design, competent, but you need to be up there. This is really important because in order to be able to talk consistently across your domain, you also need to understand technical constructs. What's a bounded context? What is a checkpoint? Do I need a checkpoint? What does a recovery look like? Do I need to have a, do I need to consider ways to separate my bounded contexts? If your rest of your team eyes are popping out of their head when you're talking about these things, you're not going to have an ability to deliver a consistent, coherent architecture. Only once you've done these 2 things can you then, in my view, embrace on the event sourcing piece itself, which is the 3rd and final pillar, and then you can be successful in building out an event sourced model. Second's the environment. So depending on how big you are, and I mean the organization you're in or the data that you're consuming, it's almost assumed that the core domain of what you're going to model in an event-sourced architecture is going to be a subset of that rest of world. Therefore, you need to make a very explicit choice around what's in versus out of your core domain. Again, focusing on where the value is for the customer. This is so important. So you need to create this safe zone. before you even start building your solutions inside the core domain, you're going to have to do a whole heap of work to transform data from that rest of world into your core domain in an event-orientated model. I call this, or Eric would call this, an anti-corruption layer, or adapters. These are things that make the world that aren't event-driven appear like they're natively event-driven. In my case, it was market data, trades, referential data that was being recorded and injected into the architecture as an event stream real time. The third piece is the architecture. Now, it may sound obvious, but we kept it as small and simple as absolutely possible as we could. And when I say simple, I mean simple. We used no third party. It was a file. We wrote a binary representation onto a file on a disk. We held the time, an event ID, and an event blob, and that was it. Sure, we had multiple files for regional, for hardware resiliency, and sure, we put them in different locations so that we had considerations around latency. But there were only 6 files. And yes, we had multi-master conflict resolution and things like that, but it was still just a file. We supported the entire foreign exchange trading business for Morgan Stanley during events like this on 6 clusters. Each cluster had its own file, or if you like, event store, but it was just a file. And they send copies of data between the nodes. The hardest piece truly was the conflict resolution, but I'll talk about that in a second. We also need to make sure we didn't smash the network with chatty conversations, but again, that was just a simple cross-region hashing algorithm. It wasn't that hard. The fourth of 5 things is about data retention. Don't retain everything forever. Yes, we have S3, and Amazon will try to pretend that it's almost free, but it's not just the data storage, it's the person who has to maintain the data being stored and what they might do with it. You can very quickly, and trust me, you can store a lot of data, especially when you're streaming real-time market data in unbelievable quantities of data. But it's really, really important that, going back to the very start, that you can always recover from your cold event log. So even if you store a derived state, often known as a checkpoint or something to that effect in eventing, you want to be confident that your log is still the root source. So whether it's daily or weekly, I strongly recommend you sort of flex those rebuild muscles and you regenerate that current state. So this becomes one of the most difficult decisions. What point do you delete data or archive data into, Glacier storage? Our review was that the value of an entity that you store in your domain does change over time. You eventually hit this inflection point where the cost of trying to reimagine how you would upgrade a version of that old set of data because the eventing model has now moved on versus the value it provides to your business hits that inflection point. I'll go one step further, is I would imagine that up front and start building it into your architecture so that from your initial build out, you're also having deliberate control around where you're going to purge your data. You don't have to delete it, but knowing that you're going to make a very deterministic decision that once it gets to 2 years old, based on your current understanding of the needs, you're going to start pruning, saves you a whole heap of world of pain when that time bomb starts ticking and you realize you forgot to build it into your system up front. And then this little thing, the speed of light. And I know it's really easy to consider and everybody's heard of it, but it's amazing how much in technology we try to avoid it or imagine it doesn't exist. This is probably the toughest of them all because, we're all engineers and we want to solve these complex problems, but you simply can't synchronize state transitions in these types of architectures. Instead, you need to embrace, and I mean really embrace, the chaos that naturally provides a big mental shift. Trying to control the sequencing of events across regions is a failing task. Instead, accept their order, accept that London's going to be out of sequence with New York, and embrace it. And instead, proactively invest in identifying conflicts so you can auto-resolve what is the correct order. If you build auto-resolution and conflict resolution, into managing your event streams, not only does it allow you to basically cheaply get bidirectional replication for free, but it also means when you have a so-called incident or a failure, it's just a normal day in the office. You're always recovering and resolving from conflicts, and that's just business as usual. And this goes all the way to the user experience, right the way through to your design. Thinking about an asynchronous design is not an afterthought. It requires tight engagement. It needs your design team working with product, working with engineering to reimagine the experience. It's fun, but it's a really different way of embracing chaos. And so with that, that's pretty much me. If I can leave you with one thought, event sourcing is an architecture that when it's fit for purpose, I truly believe it can be indistinguishable from pretty much the joy that magic will bring you. But if you apply it to the wrong use case, it will leave you sort of lost in that sort of pit of despair that I described in the game earlier.